So again, in this week, we're going to be focusing on multiple linear regression. Specifically in this lesson, we'll give an introduction to multiple linear regression, which I'll typically denote as MLR. And in this lesson, we're going to really try to motivate why we're going to move from an experimental design to a more to multiple linear regression and more observational studies. So far in this class, we've been interested in studying the dependency of a response on a set of factors, where each factor kind of has a small number of levels, whether they're fixed or random, but we required the experimenter to have control over the factors or specific levels. So we expected, for instance, if we had treatment A, we'd expect 1 or 2 levels in the experimenter to control that. Also, we expected each factor was a discrete variable whose values were categorical or groups or etc. Okay. Now, experimental designs are good to assess the factor effect on response. Okay. But what if our experimenter has no control over the factors? And what we'd call this would be an observational study. So that is me or you as the researcher. We can't go and actually manipulate certain factors. We're just sitting there and kind of watching it happen, or we're collecting data after. Also, in this case, what if our factors have a continuous scale, or they are continuous variables? Because again, remember, so far we've only really been working with qualitative or categorical variables, but we're going to start moving into continuous or quantitative variables. And then maybe something that we haven't been too interested in is, what if our new goal is to predict? So prediction at new levels of the factors and whatnot. So to really help start to understand why we're going to move away from design of experiments and maybe studies that are focused on these 3 bullets, let's talk about a fish catch example. So the problem here is that a state's fishery commission wants to estimate the number of bass caught in any given lake of the state during a season. So some of the possible contributing factors could be maybe the residence density, the size of the lake, does the lake have public access or not, or the structure of the lake. Okay, now let's first approach this example through a design of experiment approach, kind of as if we would do it the way we've done it through our entire class thus far. So in this case, if we took a design of experiment approach, we would want to specify the levels of our factors. So maybe for our resident density, we have dense and sparse. For the size of a lake, we have small, medium, and big. For our public access, they either have it or not. And then maybe for the lake structure, there's 3 kind of types of lake structure. All right. Oop, get that on the page. So we take these measurements, which are probably mostly continuous. If we think about a residence density, it's not normally labeled as dense or sparse. There's some continuous variable, maybe there's 10,000 people in a population or 20,000 people. The size of the lake is would also be continuous, just thinking about how we would measure a lake. So some of these variables are continuous, and we would convert them into these discrete levels. Then once we do that, we can now determine what the treatment are, what the blocking factors are. I would probably rely on my fish experts or my fishery commission to help me with that, to understand their problem a little bit better. Then we would randomly select lakes that fall into each of the treatment level combinations. We would record the number of bass caught during the season for each lake, and then we would perform the proper statistical analysis. Okay. For prediction, so we were going to say we get a new lake, let's say Lake Wannaweep, and we now want to figure out, hey, let's predict how many bass we would expect to catch. In this design of experiment approach, we would figure out the category of Lake Wannaweep, and then we would use the mean bass catch of that category as the prediction. So setting this up as a design of experiment might not be the most efficient use of our data in this experiment, because we're taking continuous variables and we're converting them to discrete. And typically whenever you do that, you're going to lose a lot of information. And then we also have other difficulties, such as what could be the cutoff for these different factors. For instance, if we take lake size, what's the cutoff between medium and big? Is it 100? Well, why isn't 101 kind of medium? And so making those cutoffs can be very difficult. Also, the relevant characteristics of all the lakes must be known to the experimenter to carry out the random selection. So I need to know every single thing about these lakes in order to randomly pick it, which may not be reasonable because we might not know the lake structure or it might not be available. Also, prediction by the mean response of a category isn't always the most accurate. That is, if we predict just by the mean of a group for a specific lake, that might not be the best solution for that. So this is going to motivate these difficulties or limitations, however you want to describe them, are going to motivate us carrying out an observational study and then performing multiple linear regression. So let's talk about what an observational study approach would be to this problem. So we would go out and we would randomly select a number of lakes. Now, hopefully in Stat 5615, you talked about different ways to sample. There's stratified sampling, cluster sampling, all that type of sampling from your population. You would still want to do that to make sure that you're not getting, your results aren't biased towards a certain specific type of lake. But you go out and we're going to randomly select a number of lakes. We're going to measure the factors we've talked about. But here's the thing, we're going to keep them as continuous variables or on the scale that we see them as. Then we're going to record the number of bass caught. And then we're going to perform or set up a multiple linear regression, which is a model that's going to relate these four. I'm missing one factor, but we had four factors to the seasonal bass catch by using a linear equation, okay? In an observational study, if we have a new lake, let's say Lake Wannaweep again, we would measure the factors of Lake Wannaweep and then we'd plug them back into an equation to figure out what we would predict the seasonal bass catch to be for that specific lake. All right. If this doesn't make complete sense yet, we're going to talk more about it. We're just, again, trying to lay down the roots of understanding why we're moving from an experimental approach to maybe observational and multiple linear regression. So let's relook at our fish catch example to help understand this observational study approach. So here is all the data for the fish catch example. And again, the Fishery Commission wants to estimate the number of bass caught in any given lake of the state during a season. So we're going to go out, we're going to sample a number of lakes, record each lake and the number of bass caught in the thousands. Then we're also going to record the resident density, the size of the lake, the public access or not, and then the structure index. And notice that we are actually using continuous variables for seasonal catch, resident density, and lake size. We have a binary type variable here for public access. We'll talk more about how we implement that in our future lessons. And then we have another structure index, which is on its own scale. All right. So this is now our new data. And the objective of multiple linear regression is to study the dependency of the response on a set of quantitative or continuous variables. All right. In a multiple linear regression, the quantitative variables, I might also call them predictors, or you might hear them be called regressors. I've also heard them be called covariates. So a lot of different names for these, for the terms. Then we have the response, which is related through the predictors through a linear line. Here I have linear in quotes. We will talk more about that, but this linear is in terms of the parameters. And I'll explain that more in our next couple of lessons. So we have a response, which is our dependent variable because it's going to depend on what goes into the model. What goes into the model or independent responses are our predictors and our regressors. So some of the relevant questions that we can answer with this observational study approach in multiple linear regression is how to estimate the parameters of a model, how to predict the response of a new observation. Are all the predictors or regressors, are these all important in our model? And how good does our model fit the data? So these are the questions that are going to kind of guide us through the remainder of the course as we talk about multiple linear regression. So hopefully with this lesson, you at least understand why we're going from a design of experiments to observational and multiple linear approach. Again, both design of experiment and multiple linear regression both have their place in statistics. It just depends on what you're doing and how you're collecting your data. With that, that covers the introduction of us moving from design of experiments to multiple linear regression.